Hi there. This video lesson covers covalent bonding, which is Chapter 6, Part 1. Covalent bonding is different from ionic bonding in a few different ways, and we'll discuss that in this chapter. The first way that they are different from ionic bonding, which was Chapter 5, we just finished that. Covalent bonds are bonds between atoms in which the electrons are shared. So instead of an atom giving away electrons and becoming a positive ion, and another atom accepting those electrons becoming a negative ion, and those two oppositely charged ions attracting each other. That's ionic bonding. Covalent bonding occurs when atoms share electrons. And what I mean by that is if probably the most common covalent compound or molecular compound you're familiar with is H2O, water. H2O, two H's, one O. And if I draw the dot structures for these two atoms, actually three atoms, I guess. I draw this a little differently than normal. Oxygen has 6 dots. Remember that from a few chapters ago. Hydrogen has 1 dot. And I'll draw another hydrogen over here because H2O has 2 hydrogens. What happens is they share electrons. So these 2 electrons get shared, and these 2 electrons get shared. And now, by sharing those electrons, everybody's happy. So remember, the octet rule says atoms want 8 or 0. Well, we can't share 0 of something, so when they're sharing electrons, they're always going to go to 8. So if we look at the oxygen now, 1, 2, 3, 4, 5, 6, 7, 8. So including the ones it's sharing, oxygen has 8. Hydrogen, remember, is an exception to that. Hydrogen only wants 2. So if we look at this hydrogen, it's got its 1 and it's sharing another 1. Same with the other hydrogen. It has its 1 and it's sharing another 1. So it has 2. So both your hydrogens have 2, your oxygen has 8, everybody's happy. So that's what I mean by sharing electrons. The region occupied by the shared electrons is called the molecular orbital. Covalent bonding occurs between non-metals. If you remember, a lot of our ionic compounds were a metal and a non-metal, something from the left side of the periodic table and something from the right side of the periodic table. Here, we're dealing with all non-metals. So remember, our little stairway here is our line between metals and non-metals. Stuff on the right and hydrogen are your non-metals. I'm not going to read through all these notes. I will expect you to read them, though. I just want to highlight the important stuff and get to the kind of skill-based stuff. Octet rule, very important. You know, they want that 8, so they're more stable. Covalent compounds are also called molecular compounds. They have low melting points and boiling points because the bonds are weaker than an ionic bond. And here are the rules for naming molecular compounds. If you print out these notes, highlight number 3. This is one of the most missed things or aspects of naming molecular compounds, is people want to use mono for the first element. And this will make more sense once we get to it. These prefixes, you do not need to memorize them. You're lucky. A couple years ago, I told the students they needed to. I put it on the back of your polyatomic ion sheet. So you should have one of these polyatomic ion sheets. If you don't, get one from me or print it off the website. It was linked to in Chapter 5. So you can go back to the Chapter 5 on the Moodle site, click on this, link to it, click on the link to this and print it. And on the back of that are the prefixes. So you don't have to memorize them. And these are what we use instead of doing the switch trick. So in a lot of ways, a covalent compound is a much easier name than a ionic compound. Here's some examples. You can go back and look at those if you get stuck. I think we're just going to get right into it. I'm going to bring up this list, put it over here so we can see it. And we're going to name these covalent compounds, these molecular compounds. First one, S2O3. So S2O3 is sulfur and oxygen. So we just name it in the same order. If you look back in the notes, there's kind of a confusing sounding rule that the least electronegative element goes first. Name the less electronegative element first and the more electronegative element. You don't really have to worry about that too much. All the examples I'll give you, I'll either give you the formula or the name, and you always write both of them in that same order. So you just write it in the same order that it has. Just like before, we change the ending of the second element to IDE. And again, never use mono for the first element. So let's bring this back up. And let's look at those examples again. Okay. S2O3 is sulfur and oxygen. So how many sulfurs do I have? I have 2, and the prefix for 2 is di. So the name of seriously. So S2O3, the name of that would be disulfur. And there's 3 oxygens, so tri is the prefix for 3 right up here. Trioxide. Remember the second one, just like before, second part of the name always gets changed to IDE. So oxygen becomes oxide, sulfur becomes sulfide, nitrogen becomes nitride, and so forth. Hydrogen is kind of a tricky one. Hydrogen becomes hydride. Iodine becomes iodide. So let's try another one. Second one, P5S8. So P5S8. 5 phosphoruses, P is phosphorus. So 5 is penta. Pentaphosphorus, and then octa for 8. And just like before, sulfur becomes sulfide. The ending of the second one always becomes IDE. When you pause the video, try the next one, and then unpause it, and we'll go over it. N2O2, dinitrogen, dioxide. Now I want to do one more example. It's not on there, but it's a chemical you probably heard of before. CO. Now, the way I name this is for CO, there's only one C and there's one O. And the prefix for one is mono. But remember that rule, we never use mono for the first element. So, a lot of people would name this chemical monocarbon monoxide, but we never use mono for the first one. So it's simply carbon monoxide. With oxygen, you usually drop the O from mono and any of these A's from the other prefixes. You drop that. Technically, if you put it in there, I'm not going to mark it wrong, but officially, that's not how you name it. It's not monooxide or hexaoxide. It's just monoxide or hexoxide. So, I think that's fairly self-explanatory. Let's move on here and let's go the other way. Trinitrogen hexachloride. If I give you the name, I want you to give me the formula. So trinitrogen. That means N3. Hexachloride, Cl6. Now, one thing I want to point out is last chapter, in chapter 5 with ionic compounds, if you had a ratio here, if your numbers could be reduced, you were supposed to reduce them. And for ionic compounds, you always do that. But for covalent compounds, the compounds we're learning how to do this chapter, you do not reduce them. Trinitrogen has to be 3 nitrogens. Hexachloride has to be 6 chlorides. So do not reduce. Let's do the next one here. Diphosphorus, so P is for phosphorus, di is 2, oxide, and there's pent, and pent means 5, so P2O5. The next one, you can pause it if you want and check your answer. The next one, hexasulfur, S6, octobromide, Br8. Hopefully, that seems kind of self-explanatory to you. I think this is one of those things that once you get it, it's pretty simple. It's not real tricky. You don't have to switch anything. You just use the prefixes to figure out what the numbers are. You don't have to look up the charges. You don't have to do the switch trick. You don't have to reduce. You don't have to worry about Roman numerals. None of that stuff. So, if you have questions, watch this video again, read the notes again, come and see me on one of the off days, or before or after school. That's it for this video.